Okay, so I'm going to solve the first problem that you see here. All right, does everybody see that? Okay, fantastic. So what I'm going to do now is I'm going to use the ideal gas law. So we write down the equation PV equals nRT. Okay, can everybody see that? Okay, fantastic. So then, what are we looking for?
Pressure.
We're looking for the temperature in this problem, okay? Because it says right here, what is the temperature? So we're actually focused on finding the temperature. Right. So we're going to look for the temperature. So we're looking for T. Now, if you take a look at the problem, you can highlight the key information. What's the first number you get? 4 moles, right? So there it is. Okay, what's another number? 5.6 atmospheres. Very good. And the last one is?
12 liters.
12 liters. Okay, so now all you have to do is put the numbers in and choose the right value for R. The pressure is going to tell you the right value of R. So what number are we going to use for R? 0.0821. Very good. So let's put the numbers in that we know, and we'll substitute in the gas constant as 0.0821. So here we go. Pressure, 5.6. Okay, the volume is 12. The moles is 4. The gas constant, oh man, help me out here, 0.0821. Wow, snuck it in there. And then T for temperature, all right? So now as I do my algebra, right, I'm going to divide both sides by 4. And I'll divide both sides by 0.0821. I'll do the same on this side. Well, the way that I do my algebra is my own personal style. You may have a different style, and I recommend that if you get the right answer with your style, use it. Okay? My style is to isolate the variable t. I want t by itself, so here's my t. And now all I have to do is put these numbers in on my calculator, and I'll get the answer. So, yeah, question?
So we don't do liters times atmosphere divided by moles?
Those are the units for the gas constant. Okay? Those are the units for this number 0.0821.
So you don't do any of that little steps though?
It is important to use the right gas constant with the right units. And what I'm saying is that at the regular level of chemistry, you don't have to do too much bookkeeping with your units for this equation. As long as you follow the guidelines on the previous slide, where you show that liters are, the volume is in liters, the pressure is in atmospheres, and your moles are there, and your temperature is in Kelvin. As long as you're following those rules, then the units will work out. The big mistake would be if the pressure is given in atmospheres and you use the gas constant R as 62.4. That's a big mistake because that constant matches millimeters of mercury, not atmospheres.
Oh, so 0.0821 is only for liters, atmosphere, moles, and Kelvin?
Correct.
And then the other one is liters, millimeters, and then moles, and Kelvin.
Correct.
Oh, okay.
Good job. Okay? So did anybody figure out an answer for this?
204.62.
Okay, so 2.05 and 204. I apologize. 204.62, and it's Kelvin. Okay, a little bit sloppy there with the writing. Okay, but you got the main idea, yes? All right, do you want to do another one just to say you did? All right, fantastic. Let's do one more. And let's see if I can hit the eraser. Whoop, get rid of my stray mark. Okay, and I'm going to position this a little bit differently. Whoop. All right, let's see if I can get rid of this. Oh, there we go. Okay, so it says in the second problem here, if I have an unknown quantity of gas at a pressure of 1.2 atmospheres, okay, so you look at this, you say, okay, 1.2 atmospheres, it has a volume of 31 liters and a temperature of 87 degrees Celsius. How many moles of gas do I have? Okay, so you go back to the same equation as before. PV equals nRT. Now the pressure is 1.2 atmospheres. The volume is 31 liters. The moles we don't know, that's N. What gas constant do we use? What's the value of R?
0.0821.
Good. 0.0821. And the temperature? Be careful.
We return to Kelvin, right?
Right, we have to change 87 into Kelvin. So we have to take 87 plus 273. And what do you get? 360 Kelvin. Okay, so I'm going to put my 360 in there. Can make this. Okay? And so now you have to just use your magic algebra skills and solve for n. Anybody get an answer? What did you get?
1.3 moles.
Cool. It should work out to be about 1.26, right?
Yeah.
So if I were if I were precise to 2 decimals, it should be 1.26 moles. Yay. And that's the answer. Okay? So that's the big lesson for the ideal gas law. Yes?
The third one, since you don't know the pressure, how do you choose which R to choose? Like, do you choose the 0.1
Oh,
or the other?
correct. Okay, great question. So in the next problem, it says down here, what is the pressure? And as you know, you could choose two options. You can either calculate the pressure using atmospheres, or you could calculate the pressure with millimeters of mercury. So the option is really yours, what you want to choose. On a multiple choice test, you would need to look at your answer choices.
Okay, so
And if you look at your answer choices and see that all the answer choices are in atmospheres, then you should really do the math there. Okay, so before you actually solve the problem, examine your answer choices for A, B, C, and D, because on your tests, there's going to be one unit that is given. So if you see that all your answer choices are in millimeters of Hg, then in that case you want to pick the one that matches the units of your choices.